So the topic is identification of cations. Identification of cations. So cations are one of the ions you are to identify. Cations and anions make up your practical work, and so they are separated into cations and anions. Number one of WAEC and NECO exams consists of uh, volumetric analysis, whereas number two is identification of ions. That is where cations and anions will come into play. So positively charged ions are cations. Positively charged ions are cations. And so cations for identification, here they are, about 7 or 8 of them that you'll be required to identify. And so these are calcium ion, lead ion, zinc ion, aluminum ion, then ion 2 ion, ion 3 ion, copper 2 ion, and ammonium ion. Now, from number 1 to number 4, exhibit white color. They have white color. Number 1 to number 4 have white color. So, number 5, which is ion 2 ion, is green. Ion 2 ion is green. Ion 3 ion is brown. Copper 2 ion is blue. Take note of this. This is very, very important. Once again, the color of these cations. Calcium ion is white. Lead ion, white. Zinc ion, white. Aluminum ion, white. The 4 of them, white. Then ion 2 is green. Ion 3 is brown. Copper 2, blue. Whereas ammonium ion, you are going to identify it in the form of a gas, colorless choking gas. So let us now see how and these cations will be identified. You'll be given reagents, 2 important reagents that will be used to identify these cations. There are 2 important reagents that are be used to identify the cations. These are sodium hydroxide and aqueous ammonia. Sodium hydroxide and aqueous ammonia are important reagents for identification of cations. The preliminary test identification, sodium hydroxide and calcium hydroxide are used. So now the color of the cations in the reagents. Remember we said the reagents are sodium hydroxide and aqueous ammonia. So for calcium ion, if you add sodium hydroxide to it, in drops, you have white precipitate. In excess, the precipitate will not dissolve. If you add ammonia to it, in drops, you have white precipitate. In excess, the precipitate will not dissolve. So this is easy because what you're having is just white precipitate all through, which are insoluble. White precipitate, insoluble. White precipitate, insoluble. Then you know that the ion present is likely calcium ion. Then for lead ion, you have white precipitate. When you add sodium hydroxide to it, you have white precipitate. In excess, the precipitate will dissolve. Then when you add aqueous ammonia to it, you have white precipitate. In excess, it will not dissolve. So calcium ion is dissolving in sodium hydroxide excess, but does not dissolve in the excess of ammonia or yeah. Then zinc ion. Zinc ion in sodium hydroxide, it is soluble. In aqueous ammonia excess, it's also soluble. So you can see that zinc is almost acting as the opposite of calcium. Zinc is acting as the opposite of calcium because in drop and in excess. In excess for calcium, it did not dissolve, but in excess for zinc, both dissolved. Zinc is more of obedient because it dissolves in sodium hydroxide and excess of aqueous ammonia. All right, the next ion is aluminium ion, which is not on this table. Aluminium ion, okay, Al3 plus. In excess of, okay, let me treat others, then I'll come back to this aluminium. So let's talk about ion 2 ion. Ion 2 ion. Ion 2 ion exhibits color. You have dirty green precipitate, which is insoluble in excess, sodium hydroxide. When you add aqueous ammonia to it, dirty green will be formed. It's also insoluble. It doesn't dissolve. Somehow behaving like calcium. But the only difference here is the color, which is green, the green color, whereas calcium is white. Ion 2 is green. Then you go to ion 3 ion. Ion 3 ion is brown. The behavior is just like the brother, ion 2 ion. But the only difference here is the color is brown. So when you add sodium hydroxide, if you see a brown color, then what is present is ion 3. If it's green color, what is present is ion 2. Then if it is white, what is present is calcium, lead 2 ion, and zinc ion. Then I'll still come back to aluminium ion. Then on this series, you have a copper 2 ion. The color is blue. So when you add sodium hydroxide, if you see blue color, you suspect copper 2 ion. Copper 2 ion will not dissolve in excess of sodium hydroxide. But in excess of aqueous ammonia, something will happen. It will dissolve to give a deep blue solution. In excess of aqueous ammonia, it's going to dissolve, giving you very deep blue solution. Very deep blue solution. And now for aluminium, Al3 plus. In sodium hydroxide, you have drops, you have white precipitate. In excess, precipitate will dissolve. Then for aqueous ammonia, you have white precipitate. In excess, the precipitate will not dissolve. Precipitate will not dissolve, insoluble. So you can see that aluminium is behaving exactly as lead, because here you have white precipitate, soluble. Aluminum is also soluble. Then white precipitate, insoluble. Insoluble, whereas it's also insoluble here. Aluminum and lead are just behaving in a similar way. And so your work assignment will be, how can we differentiate between these two ions? Yes, how can we differentiate between aluminum and lead ion? Since both of them are insoluble in sodium hydroxide, both of them are soluble in sodium hydroxide, but insoluble in aqueous ammonia. How then can we differentiate them? This assignment, present it in the comment area. You can just tell me in few ways. You tell me how you can differentiate between aluminum and lead ion, or just tell me the reagent. Let me make it simpler. There is a reagent you will use to distinguish between the two, and a color that they will exhibit. Just tell me the reagent and the color. All right, that is what we'll have. See you in the next assignment.